guys, welcome back. Sorry, I've named today's lesson incorrectly. Please could you comment your names and I'll get filling in the register. So we got Sam and Kezia so far. And Kara's just emailed me, so she's here as well. Anybody else we're missing? Sid. Yep. Samuel. Regan. Dan. Frank. Where's Frank? There. Cool. Still missing Joseph, Will, Zach, Sam, Lottie, Hannah, Samuel, Casper, and Isaac. If any of you guys are here, please let me know. So today I'd like to try and finish off. Oh, here we go. Sorry, who's CTA FSHTYL? Who's that? Zach. Yeah, you're ticked off. Comment your names, please, guys, if you have screen names. Yeah, so we're going to try and finish off these integrals. There's two here to start with, and then we're going to look at some of the more difficult ones on the last page, and hopefully we can get through all these today. So if you guys want to start with these two, Sam Stevens, yeah, already had you ticked off, Sam, but yeah. Cool. All right, so yeah, give these a go. The first one you might find difficult if you can't remember what the method is. Second one should be okay. Let's say 6 minutes to do these ones then. So 6 minutes starting now. Cool. Right, let's go through these ones then. I didn't realize I didn't put the timer on then. So we're doing first one there is sine cubed. All right, so do sine cubed then. We write it as sine times sine squared from 0 to pi by 4. We then write the sine squared as cos squared. So we get integral of sine x 1 minus cos squared x dx. Then expand it to get sine minus sine x cos squared x. Then the sine's going to integrate to give us minus cos. And this one, we have a function times its derivative. So we've got function squared. So we're going to try fx to the n plus 1. So we're going to try cos cubed. So if you differentiate cos cubed, you get a 3 out the front. We don't want the 3, so we need to divide by 3. But you would get the minus, so that's fine. So we're going to get this as our answer. So just quickly check that through. 3 cancels the 3. 3 goes down to 2. Cos differentiates to minus sine. So yeah, that's all makes sense. Then we just need to put limits in, which are 0 and pi by 4. So we get minus cos pi over 4 plus a third cos pi over 4 cubed. Take away minus cos of 0 plus a third cos of 0 cubed. Right, so if you work that out, minus, make sure you're in radians, minus cos pi over 4, which gives us minus root 2 over 2, plus 1/3 root 2 over 2 cubed. Cos of 0 is 1, so we're taking away minus 1. Plus cos of 0 is 1 times a third is going to be a third. So we get this. So that's going to give us so we get minus 5 root 2 over 12. Minus minus 1, which is plus 1. Take a third, it's going to be plus 2/3. So we get that. Cool, Joseph and Hannah as well. I'll take you guys off on the register. Cool. Okay, so that's the first one done. Second one, a little bit easier. We're going to be using by parts twice. So for the second one, u is going to be x squared. No, it's not. U is always ln, so u is ln x. dv by dx is x squared. U dash is going to be 1 over x, and v is going to be x cubed over 3. So we get x cubed over 3 then x minus the integral of x squared over 3 dx. So we get that as our solution. Put in 1 and 2. So we're going to get 8 over 3 and 2. Take 8 over 9. Subtract. Put 1 in. Ln of 1 is 0. So we're taking away minus 1/9, which is plus 9. So we get 8 over 3. Ln 2. Minus 8/9 plus 9 is going to be minus 7/9. Cool. Right. Anybody got any questions on either of those two? Alright, so we're going to move on to the next set. Next set is the hardest set of integrals I've managed to find, which says a lot. So, I'm going to try these. It says further maths integration. They're methods. You guys can do all these methods too. They're just very hard standard integrals. So I think we'll work through these in sets of 6. But I'll leave all 9 up in case you want to move on to the next ones. So we're going to go through these first 6. I'm just going to renumber them because it's printed wrong, and that should be a 5, and that should be a 6. I'm going to give you some hints because some of these methods are pretty horrible. So to do 5 and 6, we're going to make x equal 3 over 2u. It's going to be substitution, and you might need to use 2 substitutions. So you might need second substitute. So that's those two. First one should be pretty straightforward. Second one straightforward. Third one is a recognition. Fourth one is a partial fractions. And then 2 horrible substitutes. So if you guys try those 6, I think I'm going to give you 20 minutes for this because they're pretty horrible. I don't want it to be 20 minutes of you guys sat in silence, though. I'd like you guys to try these. Please comment if you need help, hints, or if you've got an answer. I don't want to just kind of leave you to it. So make sure you're commenting if you get stuck. If you want to send me your workings, you can send them to Google, not to Google Classroom, to the Microsoft Teams. Yeah, I mean, those hints should help, but I imagine most of you will find 5 and 6 challenging. All of these, to be honest, should be challenging. But if you need any hints, please let me know. So I'm going to give you 20 minutes to do these, which hopefully will be enough time. We'll see what happens. So 20 minutes starting now. Yeah, looks good, guys. Keep it up. Yeah, doing really well, guys. Keep it going. 5 and 6 is where it starts to get quite hard. Cool. All right, how did you get on? So, looks good up to 4. Cool. Right, let's go through them. And I might go through 5 and then give you guys like a few minutes to try 6 once you've seen how to do 5. Just because it is a bit trickier. Okay. So first one, if I make some space. Might do that thing where I take a picture of some paper. All right, so let's do this first one. Cool. Okay, so first one, we're going to try to the power 6. So if we differentiated that, we'd get a 6 down the front, which we don't want. We get a 4 down the front, which we don't want. So we need to divide it by 24. Which is, I believe, what you guys all said. Yeah, good. Nice and easy. Second one. Similar kind of thing. If you differentiated the bottom, we'd get 12. So this is going to be a f dash x over f of x1. So we're going to try and learn the bottom. No, we're not. That's a load of rubbish because it's cubed. We're going to bring it up and do a negative power. So 5 is minus 3. So we're going to try 4x take 9 to the minus 2. We differentiate that, we'd get minus 8 out the front. We've got 5, so we need to divide by times by 5, divide by 8. Which is what you guys have said as well. Good. Question 3 is one of those function derivatives because we've got 5x on top, fx on the bottom. So we're going to do learn 4x squared take 9. Now if you differentiate this, you get 8x out the front. We don't want 8, we want 5x. So we're going to divide by 8 times by 5. Yeah, which is what Dan and Frank and Samuel and Kezia have all said. Good job, guys. That's the first 3 done. All right, let's move this up then. So 4, 5, and 6. Remember these again. So 4 is a partial fraction question, and I can tell because the bottom factorizes quite nicely. So we get 2x minus 3, 2x plus 3, difference of 2 squares. So that's going to be a over 2x minus 3 plus b over 2x plus 3. So we get 5 equals a 2x plus 3 plus b 2x take 3. So we're going to say x equals minus 3 over 2 and x equals 3 over 2. So for minus 3 over 2, so we're going to get rid of the a bracket. We're going to be left with 5 equals minus 6b. So therefore b is minus 5 over 6. If we do the same thing for a, we get 5 equals 6a. So a is positive 5 over 6. So we go back to our initial integral. We're going to put in b. Now there's a number of ways you could do this. I'm going to say a is 5 over 6 like this, and b is 5 over 6 there. Tweak that sign to a minus. Now you could expand those brackets. I don't think I'm going to bother. I'm going to instead say take 5, 6 out of the entire integral. So we're going to get 5, 6, the integral 1 over 2x take 3 minus 1 over 2x plus 3. Just, I think it makes things a lot easier. We not have to worry about it till the end. So we'll get 5 over 6 ln 2x minus 3. And now if we differentiate that, the 2 would come out as well, so we need to divide by the 2. So we're going to get 5 over 12, 2x minus 3, minus 5 over 12 again, ln 2x plus 3. And we can combine all the logs to make it 5 over 12 ln 2x take 3 over 2x plus 3. Cool, which Dan agrees with, but he's not simplified. Okay, so question 5 and 6. 5 first of all. So I gave you guys the hint. Use, what did I say? X equals 3 over 2u. So if we differentiate that, dx by du is 3 over 2, and we know dx is 3 over 2 du. So my integral is going to become the integral of 5 over 4 lots of 3 over 2u squared plus 9 times by 3 over 2 du. So if I keep working this through and simplify, we're going to get 5 over 9u squared plus 9 times by 3 over 2. I'm just going to put the 3 over 2 out the front. du. Okay, 9u squared plus 9. How we're going to differentiate that is using trig. So I'm going to take out a factor of 9. So get rid of these 9s, put them outside here as an 18 on the bottom. And I'm going to take the 5 out as well. Why not? So I'm going to make it 15 over 18 times 1 over u squared plus 1. So I've taken everything out that I can. Now it's going to be a trig substitution. U squared plus 1, if we make u into tan or cot, this will be really easy to do. So I'm going to say substitution 2, u equals tan. Sorry. U equals tan p. The du by dp give me sec squared p. Let's put it all back together. So we're going to get 15 over 18, 1 over tan squared p plus 1, and then du is sec squared p dp. Okay, running out of space here, but that's all right. So tan squared plus 1 is sec squared. That's an identity. 1 plus tan squared is sec squared. So this integral will become 15 over 18 integral of sec squared divided by sec squared, which is the integral of 1 dp. Cool. Okay, definitely running out of space. I'm going to get rid of everything apart from my my decisions as substitutions. So my x substitution there in red. I'm going to leave my u substitution there in green. So we've got the integral of 15 over 18 times by 1. So the integral of 1, in this case, is going to turn to p. So we've got 15 18ths of p. Now I know p is going to be arctan of u. And I know u is 2/3 of x. So we get 15 over 18 arctan 2/3 x. There we go. So that's the first one. I'm going to give you guys a few more minutes to try the second one. The same kind of idea. We're spotting, u is x is 3 over 2u again, but it's going to be a different type of trig substitution. So 5 minutes, I think, sounds fair. 5 minutes, see if you guys can do it. This is a hard integral. See how you get on. If you do finish it, I will reveal the next few questions as well. So if you want to make a start on those, you can, because we're going to do these in a minute. Cool. Right, let's have a look. So, same idea. U equals, or x equals 3 over 2u. dx by du 3 over 2. dx equals 3 over 2u, 3 over 2 du. Okay, so the integral is going to turn into 5 over square root of 9 squared plus 9 times 3 over 2 du. So same again, I'm going to take out 15 over 2. Like this. And, well, now we can take out a factor. We're not going to take out a factor of 9 this time. We're going to take out a factor of root 9. And root 9 is, of course, 3. So we're going to get 15 over 6 integral square root u squared plus 1 du. We get that. Okay, so this time again we're going to use the tan integral tan substitution. So u equals tan p du over dp sec squared p. So our integral is going to become 15 over 6, the integral of 1 over root tan squared p plus 1. Sec squared. I'll write sec squared on top, save some space. Sec squared p dp. Okay, so as we saw before, tan squared plus 1 is sec squared. This is going to turn into the integral of 15 over 6 sec squared p over sec p, which is going to turn into 15 over 6 integral sec p dp. So make some space. Now, integral of sec is in the formula book. You might remember the integral of sec is ln sec p plus tan p. As far as I can remember, it's been a while since I did this one without the formula book. I'm going to Google it. I think that's right, but I want to give you guys the right answer. Integral of sec is ln sec plus tan. Yeah, good. Still got it. Okay, where's the chat gone? Okay. So we're almost done, but we need to put it all back together. So remember P. No. What do you say? U equals tan P. And I've lost where I was going now. Was U tan P? Have I done something silly there? Had U on the bottom. I said U is tan P. No, that's fine. U is tan P. So arctan U is P. And I know that U was equal to 2/3 x. So arctan 2/3 x is P. So let's try and put all this back together. So I'm going to substitute this in wherever I see P. So we're going to get 15 over 6 ln, brackets wrong there. I'll do it at the bottom. 15/6 ln. Now sec P is going to be sec of arctan 2/3 x. plus tan p of arctan. Tan of arctan is going to cancel. We're just going to get 2/3 x there. So yeah, plus c. That's my integral for number 5 there. All right, has anybody got any questions, or is that okay? Horrible integral. All right, the next ones aren't so bad because they go back to being trig. How long we got? 30 minutes. Yeah, maybe we won't finish these today. I'm still doing these in my other group, so if you have to spend one more lecture, it's fine. It's a little bit of a challenge. Okay, next ones we got these 3. Should we try and do 6 more or 3 more? What are the 6 like? Pretty horrible. I'll put 6 up. You guys can't really see those. 6 up. And these labeled right 6, 7, 9. Nope. So that should be 7, 8, 9. Whatever. 7, 8, 9, 10, 11, 12. Yeah, good. Okay. So yeah, another. What have we got left? We've got a half hour left. If I give you guys 15 minutes, we'll see how far you get. Yeah, I think 10. I think you'll struggle on. It's similar to how we did sine cubed at the beginning of the lecture, though. Yeah, we'll just see what happens. So 15 minutes, see what you guys can do. Cool. All right. Let's go through these. So, yeah, the question 7. Let's start with. So, Dan, looked like you did pretty well. No 11, but you got the rest done. It's pretty good for getting 10 done. That. Oh wait, I don't know about 10. All right, let's go through these. So this will probably be it for today, and we'll come back to the rest of these tomorrow. So first one is spotting you got double angle here. It's actually, it'll be 4x instead of, basically, sine x cos x times 2 is sine 2x. We've got that. The only difference is our angles are already doubled. So what we're going to get is the integral of sine 4x, which will turn into minus a quarter cos 4x. So, yeah, well spotted there, Dan, for that one. Yeah, good. Next one, we need to turn the bottom into cos, because we know 1 minus cos squared is sine squared. So we're going to get integral of 2 sine x cos x over sine squared x. So the sign on top is going to cancel one of the signs on the bottom, leaving us with cos over sine. Cos over sine is cot. So we've got the integral of 2. Actually, let's leave it as it is. Cos x sine x. And let's do this by a recognition. So recognition, we're going to get ln sine x. 2 ln sine x for question 7. So again, well done there, Dan. Well, that was question 8, I guess, technically. Question 9 here is another recognition question. So we got a function f of x to the n times its derivative. So we're going to try cos to the 8. We need to divide by 8, and cos would differentiate to give us minus sign, so we need to throw a minus. Haha, we need to throw a minus sign in there as well. That was an awful pun. Okay, so those are the first 3. Let's move it down, or move it up indeed. Here's 3. Okay, cos to the power 7. This is horrible because of the amount of time it's going to take. We can't just kind of integrate it. Like I said, Dan, your answer would be wrong. If you try and differentiate your answer, you'd get a sign, and there is no sign here. So how we do this is we split it up. We say it's cos squared x times cos x cos to the 5x, which will turn into 1 minus sine squared times cos to the 5. We're now going to expand that to get cos to the 5 minus sine squared cos to the 5, which still isn't quite there. We need to turn this into, we need to get a power 1 in here somehow. So we're going to do it again. So let's go. Cos to the 5, let's say it's 1 minus sine squared, so cos squared times cos cubed, minus the same over here, sine squared, 1 minus sine squared x, cos x to the 3. So you can see why it's going to be so tedious. Still not good enough, we've got to do one more. So I'm going to expand all this and then do one more. So we're going to get cos cubed minus sine squared cos cubed minus sine squared cos cubed plus sine to the 4 cos cubed. Yes, okay. So we're going to change all the cos squareds into 1 minus sine squared times cos. Really isn't much space there. And we're going to expand the whole of this to get cos minus cos. I'm going to get rid of the x's, which I know is really bad maths, but purely to save space for now, we're going to get rid of x. So we're going to have cos minus cos sine squared minus 2 sine squared cos plus 2 sine to the 4 cos plus sine to the 4 cos minus, sorry, that should be a sine in that bracket. I made a mistake there. That should be sine to the 6 cos, which we finally are able to integrate via recognition. So I'm going to write it out one more time with the x's back in, simplify it because there's a couple terms there that are doubled up. Oh my god. Please don't say I deleted that. Come on, iPad. Everybody, yes, cool. All right. So let's do that again, but without doing whatever I just did. I don't think this would ever come up in an exam because it would take forever and it doesn't really test anything that doing a cubed one doesn't. So we got cos x minus, we got cos sine squared. There's two of those, so we got minus 3 cos x sine squared x plus 3 sine to the 4 x cos x plus minus sine to the 6 x cos x. All right, and now we do each of these integrals separately, and these are all recognition. So cos integrates to give us sine x. Here we're going to try sine cubed x. Sine cubed would differentiate to give us 3 cos sine squared, so all we need to do is introduce a minus there. Next one, we're going to try sine to the 5x. Now we've got 3, we want 5, so we need to, sorry, we've got 5, we want 3, so we're going to get 3/5 sine to the 5. And the last one, we're going to try sine to the 7. We need to divide by 7. So that's what you should get for this. Sine minus sine cubed minus 3/5 sine to the 5 minus 1/7 sine to the 7. Horrible question. Horrible. Okay. Question 11. Sine to the 4 cos to the 7. For this one, I wonder what the best way to do this one is. I could do it by substitution. Sorry guys, I sent you some really long-winded questions. We need to get it all into one type of trig. Overall, we've got an odd power. So I think the easiest way to do this one, to be honest, is to keep what we had for the last one and times every single term by sine to the 4, because you already had it as 1 cos times sine, 1 cos times sine, 1 cos times sine. Let's skip this. I think it's doable. It's the same method as we just did, but because it's a 7 and 4, let's not bother. The next one is going to be, we could write this one as sine x cos to the minus 7x. So we're going to try cos to the minus 6x, which will give us minus 6. Cos of minus 6 times sine, so we need to divide by that. So that's what you get for number 12. So Dan, yeah, good job there, but you needed a minus sign. 11 would take ages, so let's leave it. Is that all I set you guys to do? Yeah, so there's a few more here. We'll look at these on Thursday. Maybe let's get a head start on them though. So if you guys fancy a challenge between now and Thursday, here's some more integrals. I will give you a clue as to some of these, I think. So which ones am I going to give you a clue? 17 is a substitution. You need to do substitute twice. U is ln x, and then P is ln U. So that's for this one. There's some by parts in here. Once we've got 12. Yeah, give them a go. They're all doable. They're all either by parts substitution or recognition. Oh, there's a long division. I think 18 is long division. 19 is a partial fraction. 13, I think, is double angle formally. 14 is recognition, I believe. 15 is going to be some kind of substitution, I think, there. No, 15 could be recognition as well. So yeah, there's a few ways of doing these, but if you guys could have a look at these, I imagine you're going to get a bit stuck. What's Stan saying? Surely cos goes to minus sign. Oh, from the power. Yeah, no, you are right. Sorry, the last one I did make a mistake there. Yeah, it should have been positive, not negative, because the negative came down from the power. But yeah, so if you guys could try these ones, there's 8 there. Try them. Don't spend ages on them. Move on if you get stuck, and I'll give you some more hints on Thursday when we come back. That's it. We'll finish integration on Thursday, and then Friday we'll move on to some maybe area integrals or something a little bit different, because that's enough ridiculously hard integrals. Cool. Right, cheers guys. I will speak to you all on Thursday. Thank you.